Good morning. Thank you for joining me today. So I'm going to talk about how Autodesk securely develops and tests PII pipelines with Airflow. Let's get started. A quick intro about me. I am Bhavesh Jaisinghani. I'm the data engineering manager at Autodesk. I'm based in San Francisco Bay Area. So for the agenda today, we're going to start off with tech stack of what it looks like at Autodesk. I'm going to go into the background challenges and impact on why we are doing this, and this will set the context for the presentation. Moving on, we'll go into testing strategies, what the ideal environment looks like, and then how we laid the foundation and the development flow after we started using the new environment. And then finally, I'll end with some metrics and outcomes in conclusion. So let's talk about tech stack, which is the backbone of our data platform and operations. Like any other organization, we have ingest, transform, storage warehouse layer, and the BI reporting layer. What my team primarily focuses on is on the transform to the BI layer. The ingestion is done by a separate team. So as a product data engineering team, we're mainly focusing on writing business rules and then moving forward. So we use Spark, heavily work on Spark. And I want to highlight on the lake where we have Hive and S3. Hive we use primarily for cataloging, and the data is actually stored on S3. So most of the tables are external tables. And then we have Trino, which is the query engine that is looking into Hive for the catalog, and that's where most of the analysts and our BI reporting, they connect to. And for orchestration, we use Astronomer Airflow. So let's define some rules of the game. Each and every use case is unique for each and every company and team. So I want to set some background and the challenges that we were facing and why we went with the solution that we went with. So a little bit of a background. My team is a product data engineering team. We focus on data transformation to the BI layer. We have constantly evolving business rules that we update. We focus mainly on the scale and optimization of Spark scripts. We have growing data volumes, and we have high emphasis on data accuracy because of the nature of the data that we are dealing with. We have a dedicated data platform team within Autodesk, and they have implemented the multi-tenancy model. So each data engineering team are tenants, and they have their own instance of Airflow, clusters, and everything that we saw. We also have like a dev stage and prod environment set up on the different AWS accounts. This kind of sets the pre-context of the challenges that we face as a data engineering team. So as we have like 3 separate environments, and since we are mainly dealing with change in the business rules, we are constantly changing the Spark scripts, we want to be able to test our data on the production-like environment, or just doing that on the sampling basis doesn't really cut it. So there are security concerns on copying the data from a prod environment to the stage or dev environment, because those are separate environments, and then moving the sensitive data to a non-prod environment really requires a lot of approval. So that takes me to the second one, where even if we go ahead with that, it would require multiple approvals because of the data, kind of data that we are dealing with. We have limited AWS access. We could probably copy the data ourselves, but given the environment that is set up for us, we have very limited access to AWS. And then we can also not copy the data locally and do the development because of the sensitivity. So this has huge development impact because the experience is overall fragmented. Engineers are developing locally where they're running test cases, but they're writing some functional queries and test cases on the server, and they're not able to fully run their complete Spark logic. So this leads into long development and testing cycles, fragmented developer experiences, and then rise of cowboy coders, which is basically like, it's the environment that we enable them to work on that gives a rise to these cowboy coders, which are directly developing and testing on production. So that was a huge concern. And before we move on, I want to talk about different ETL test strategies that we deploy at our team. So code testing, we have unit testing, syntax testing. Data testing, we have smoke testing, which includes DDL, duplicate null count. Data dependency checks are also there. Functional tests and data quality checks can also be scheduled on the pipelines. But the ones that I've highlighted in the blue, data regression testing and the ETL performance and data load testing, are specifically the kind of test where we require a lot of data, or the data that we have in production at that level. All of the other tests can be done independently on a non-prod environment. So what does our ideal environment should look like? And so this is where we want to ensure that our data dodges the bullet. So the ideal UAT environment should have production-like environment data. It should help with the historical load, and it should minimize the production overload on our production clusters. It should support all these different testing that we just talked about. It should not have any impact on the production tables. Like whatever you do on this environment should stay in this environment, but at the same time you're kind of connected with the prod environment. So for most of the people, this UAT environment would be like a pre-prod environment or a pre-release environment. So this is what we're like doubling down on, where engineers can run their pipelines and have no impact on the production tables. And then finally, it should support multiple developers working on a monorepo. So there's a little bit of backstory in this point. When we were on Apache Uzi, we were in a polyrepo kind of structure. And at the same time, we were trying to move to Airflow, and that's where we looked into different solutions out there, and we went with the Astronomer. One specific reason for monorepo is that we could reuse the code as well as develop the features of the pipeline in such a way that we're not making multiple copies of the same code in different pipelines. So laying the foundation, this is how we did it. We first mirrored the Hive schemas for UAT. That was the first one. Just tackle at the database, create separate schemas for Hive environment. And moving on to the infrastructure, we have separate EMR clusters for that UAT environment. This also allowed us to set some additional guardrails where the UAT environment should have no access to interact or write any kind of data on the prod S3 buckets or environment or anything like that. So having this separate EMR cluster solves two of the problems where our production clusters are not overloaded. We can run our historical loads on these separate UAT clusters. And at the same time, if any developer is trying to write to the prod schemas, then this would stop at that point. We also deployed separate Airflow UI servers for each developer. This was really possible and easy with Astronomer, which allows having multiple workspaces that are at the tenant level, and then each tenant will have their own set of deployments. And then the main focus, which really enabled us to leverage the changes that we made on the database and the infrastructure, was CI/CD and developer utilities. So we created common functions to sync the tables from prod to UAT. Since all the tables that we had, they're mainly like external tables. So if we just repoint the S3 location to the production tables, we could read the data from there, but for writing, we would write it in the UAT schemas. So we created some utilities to sync the tables from prod to this new environment. We created standard CI pipelines that can deploy on any deployment node on Astronomer for any engineer. So it's not like, we have 10 deployment nodes, we should have 10 different CIs. We created a standard CI pipelines for that. We also enabled the autoload of the UAT environment variables on deployment. This was possible with Astronomer. So if we look at the code that we are deploying on these UAT Astronomer nodes, that's where it would automatically identify that I want to run all of my job on the UAT structure and not on the production structure. So this takes away some of the pre-work that the developer needs to do before they do their testing. So that minimized any human error. And then finally, the framework for regression testing of tables in UAT and prod. This was really important for the code changes that we are doing, they're mainly on the data and not on the schema changes. So what we want to focus on is if you're making changes to one column, the change should be limited to only one column, and all the rest of the 9 columns in the table should stay the same. So this regression testing would compare apples to apples and then give us a result that change is only there in this one column. That would raise our confidence, and it would really streamline our PR process as well. Otherwise, previously how engineers used to do, they would just do the functional testing, take some screenshot, put it in the PR. Developing these utilities for engineers to move faster really helped us. So this is what the development flow looks like. Like before the UAT environment, we would develop and test locally. We have unit test cases for each of our functions. We would validate the data logic with functional testing, and then we would confirm with our stakeholders that if this data looks correct, and then we would promote to release and deploy to production. But then when the data is deployed to production, we would realize that, since we just tested like a few use cases, there's some issue with the data. It's not working on some set of data. So engineers would apply the hotfix for data quality issues, or address the Spark performance issues as well. And then they would redeploy. And then after UAT, the unit testing stayed the same, but now engineers, they're syncing their environment between production and UAT. One could argue that you could have a scheduled job that would automatically sync everything from prod to UAT. Those are, like, we considered that, but again, it's on per use case basis. We don't want to just keep on running these redundant jobs where we just need, like, out of 1,000 tables, we only need to sync 100 tables on a daily basis. So we kind of kept this as an ad hoc basis. And then after we sync the environment, we would deploy the feature branch to the UAT Airflow node. We would perform stress testing, validate end-to-end outcomes, confirm whether the final table looks as expected, rather than just confirming with our stakeholders on the high-level numbers. And then once we get the approval, we would promote to release and deploy to production. So let's take a look at outcomes and metrics in conclusion. We improved product discovery because we could ideally work with the full set of data that also supported a lot of experimentation for building new data processing logic. Also helped us identify performance bottlenecks, optimize Spark jobs. The average Spark job optimization tech debt was reduced by 60% because we're running that whole job on UAT itself. Improved error identification and data quality of our data outputs by 90%. We started to deploy our code to production 33% faster. And then finally, this also improved the testing of our infrastructure upgrade, where we've moved from Spark 2 to Spark 3. We have done EMR version upgrades as well, package management. So it has also enabled our infrastructure team to just confirm right before all those changes are deployed to production. Yeah, so that's the conclusion. And then this was the feedback that we got from Astronomer when we were onboarding, and we were kind of trying to set up this environment where they share this feedback.